I'm going to show you an example of finding the force along a chord or line. First, we have to draw the situation. What I'm going to draw is a rod with a cord pulling on it. Now, the coordinates and the geometry matter here. So let's get our X and Y and Z axis. So here I've got this cord or a line pulling on the rod. So I'm going to draw a vector from the point where the cord starts to the point where the cord ends. I'm going to call that vector RAB because it's going to point from point A to point B. Now a vector has the arrow over the top of it. So let's figure out what each of those positions mean. In the I-hat direction, in other words, in the X direction, this cord is pulling +2. In other words, in this direction, the X direction, the cord is pulling 2 feet. I'm going to leave off the units and do everything in feet for now. In the Y direction, it's a little bit hard to tell, but this rod is 3 feet, and we've only gone over 2 feet right here, so you can see that the cord is actually pulling backwards a little bit, and it is -1 in the J-hat direction, in other words, in the Y direction. Also, in the Z direction, it's not pulling up, instead it's pulling down, and it's pulling down by amount of 2 feet. K-hat is associated with the Z direction. All right, the whole purpose of this question is to find the force on this cord, or the force within the cord. So let's find the length of this cord first. The length of the cord, in other words, the magnitude of this vector RAB, is the square root of all the components squared and added together. And remember that even the negative signs are squared here, so everything inside is going to be positive. And you get the square root of 9, in other words, 3, and let me add the units back in. And we have a cord that's 3 feet long because we're actually talking about a physical cord. Now we need a unit vector pointing in the direction of the vector RAB. So a unit vector, let's call it U, and it is a vector, so you can put a sign over the top of it, an arrow, is equal to the vector divided by its length, divided by 3 feet. And now we're just left with a vector in a direction that has a length of 1. And what you're going to get is, okay, so this is a unit vector in the direction of the cord. There's one final step. We've got to find the force that cord can withstand in this direction. Now let's find the force in the direction of this unit vector if the cord can withstand 20 newtons. That means the force is equal to the force that it can withstand times the unit vector. Yep, that's the equation. 20 newtons. And what you'll get when you calculate this out, basically it's going to be 20 times each of the components. So now I've got the force along a cord.